Hello, hello, somebody. Hello, hello, wherever place you are. I'm David Kyle, the owner of the channel, the YouTube channel, the Teacher Kyle Explains, especially containing chemistry and some physics or principles in it. Now, do me one favor. Make sure you like, you share, but more and more, make sure you subscribe to my YouTube channel. Teacher Kyle Explains. It contains a lot of things, especially that are meant for our learners in school. Now, without much ado, let's go directly into our class. Thank you. Now, today I want us we look at the Bunsen burner, especially even more and more. We want to look at the sources of heat. In the lab, we can have the spirit lamp, we can have the candles, we can have the stove, we can also have the electric heater. The stove are divided into two. We can have the kerosene or we can also have the gas stoves. Now, because all these ones here, actually they are sources of heat. But more and more, the one we do make use of, especially in our laboratory, is the Bunsen burner. And Bunsen burner contains three main parts. These ones here are the main parts of the Bunsen burner. Number one, we've got what we call the chimney. We have what we call the collar. We have what we call the base. In the next slide, which I've prepared for you, I will show you what is the chimney. I will show you what is the collar, what is the base. But more importantly, I want you to understand that the chimney is that metal. It is a metal in itself. Also, a collar is a metal. The base here, you can get the base which is made of a metal, or you can also get the base that is made of another material. But I want to tell you the purpose of the base. The base most of the times is meant to stabilize or to put that Bunsen burner in a stable condition. The collar, this one here usually contains the hull. The chimney is that hollow metal which we join together. So when the chimney, when the collar, and when the base are joined together, you get what we call the Bunsen burner. Very good. Now, let's go to this. This is what I was telling you. This is what we call the chimney. It is a hollow metal which contains it's a hollow metal which contains a hole. You can say hole here. And now we also have what we call the collar. This collar here contains the air hole. It contains the air hole. So when you close the collar, or when you close the collar, or when you open it, it will determine the type of the flame which you are also producing. And I don't want to go ahead of myself because I will explain that one when it comes to that. Now we have what we call the gas inlet. We have what we call now the base. These ones here are what we call the components of the Bunsen burner. We have the chimney, a hollow metal, the collar, which its purpose is for closing and for opening. We also have the jet, we also have the gas inlet, we also have the base and all that. Now, let me tell you that these ones here are not for decoration, but they've got their own purpose. For example, when you look onto the gas inlet, this gas inlet that you can see here, its work is to connect now the Bunsen burner to external source of laboratory gas. Because, for example, if you're using a methane gas, how will you take that gas and put into a Bunsen burner? We use what we call the gas inlet. Now, we also have what we call the jet. This jet here is to allow now the gas, the lab gas now to enter into the collar, and now so that now from the chimney and all that one we ignite what we desire. So the jet is to allow the lab gas, but the gas inlet is to connect the Bunsen burner itself to the external source of gas. Now, you are wondering, what kind of hole is this? What kind of hole is this? It is what we call the air hole. And the purpose of the air hole is to allow the laboratory gas together with the air from outside, to mix up. So that the moment they mix up, we have what we call the lab gas and the air. These ones here are the gases. Remember, air is a mixture of gases. Very good. Therefore, the lab and the air will come together. The moment they come together, and when you ignite them, you will produce what we call the flame. And therefore, what is the flame? The flame is a mass of burning gases. Why are we saying gases? Because there is lab gas, there is also the air, which contains a mixture of gases. In fact, in this area, we talk of oxygen because it is the one that supports combustion. Very good and very nice. Now, that is what you need to understand and know in that aspect. Now, when you talk of a Bunsen burner will produce two flames. We have what we call the non-luminous flame, or we have what we call the non-luminous flame. A luminous flame is produced when the collar, or when you adjust the collar in that the air hole is closed fully. But when you open it gradually until it is fully opened, it changes from being a luminous flame, being a yellow flame, bright yellow flame. Now it gets into what we call a non-luminous flame. What is the color of a non-luminous flame? The color of a non-luminous flame is mostly blue. It's blue in color. The gas that you do use at home, that is an example of an unluminous flame. But the candle that you use at home, especially when the power, like for example, we are also living in the country where now we get the power blackout each and every time, and you make use of your candles. We are saying that the candles are examples of what we call the luminous flames. Now, this one here is a luminous flame, and this one here is a non-luminous flame. And I want you to look into this. I want you to look into it very keenly, because it's very important for you to know that for sure when these two are combined together, it's good for you to understand that they are very important, especially when it comes to the heating in the laboratory. Now, I want to show you something that you need to understand and know. There, and then. I want you to get it, and to get it very clearly. Are we together up to that point, my learner, wherever place you are? Now, look at this. This first part here that you can see, which is part A, is what we call the thin outer pale blue zone. Thin outer pale blue zone. This part B here is what we call the bright yellow zone. And this part C here is what we call the blue zone. And the one that is in is what we call the almost colorless zone. Why are we saying it is almost colorless zone? It's because in this place here, we have unburnt gases. But when you talk of this outer part is usually the one which is somehow hot, because this luminous flame here, it is not used for heating, but this luminous flame is used for lighting. That is what you need to understand in terms of their functionality. This one is used for lighting, and this one here is used for burning, or used for heating. Now, this A here, so I'm saying that this one is for lighting and this one is for heating. This one here has got 4 regions. This has 3 regions: the pale blue zone, the green blue zone, and the almost colorless zone. Region A are the ones which are the hottest regions that you need to understand and know. Then part D and part D here, which is almost colorless, and part C here, which is also almost colorless. These ones here, they are not hot. In fact, if you were to take a piece of paper and you dip here, or you dip here, in fact, it will not even burn, because in those places, or in those regions, there is nothing like heat. There is nothing like a hot temperature in heat. That is what you need to understand. Now, the reason why do you think this one is a yellow in color is because we are saying that because this luminous flame contains what you call the unburnt carbon particles. The moment you heat them, they produce the soot, and that is why when you take your sufuria and you put it in a source of flame, which is a luminous flame, which produces a luminous flame, you will get a soot because of unburnt carbon particles, which you need to understand there. And now, in the laboratory, we usually advise the learners that the moment you get into the lab, and make sure once you are done with your experiments, if you are using a non-luminous flame, you turn it into a luminous one in order to avoid the kind of accident that do happen in the lab. We don't want people to get burnt. We don't want people to get messed up while they are still there. That is what you need to understand there. And I want you to understand that if you are to take amount of water and put it here, or in a sufuria, put it here, at the same amount of water you put it again here, you will realize that in a luminous flame, they become in an unluminous flame, they become very hot. But in a luminous flame, they are not that hot. Why? Because this one here does not produce much heat. It produces much light. This one here produces much heat. Are we together up to that point? If you are to take also a piece of paper and you put it here, and also you put it again here, you will see that in this place here, it will be burnt completely. But in this place here, it will not be burnt completely. The same thing with this luminous flame. That is what I want you to understand in this case. So just bear in mind and put in mind that there are two types of flames, luminous flame and non-luminous flame. Up to that point, I want to say thank you, and make sure you tune in to my classes. And that is all that I have for you today. Thank you so much. Make sure you subscribe to our YouTube channel, Teacher Kyle Explains. Thank you.